Mr. Kubo, the floor is yours. Thank you.
Thank you. Yes. Hi. We are a clean tech and climate tech startup based on chemistry and material science. And we have three technologies that we are developing: batteries, catalyst for chemical recycling, as well as adsorbent for carbon capture, as capturing CO2, and we make glass out of it. So today, let me a little bit explain about plastic chemical recycling for plastic waste, but also organic waste. So we call the plastalyst, it's catalyst for plastic waste. As you know, the plastic waste and waste issues is a big problem, and it emits a lot of CO2, mainly from CO incineration and methane as well. So there are mainly three methods to recycle plastic waste. So mechanical recycling, thermal, and chemical recycling. So what we do is chemically decompose plastic waste into monomers or hydrogen, so that we can semi-eternally make new polymers or plastic from monomers. So each process has pros and cons, but the advantage of chemical recycling is that we can tackle not only simple plastic waste, but also dirty, mixed, and multi-layered plastic waste as well. We have successfully almost any kind of plastic waste. So not only PET, but also PP, PE, which are main plastic that are being used, but also PVC, polyurethane, polyamide, and different plastic waste as well. And we are the first one in the world that successfully decompose PET into methanol, so not just ethylene glycol. We have successfully filed a patent on this process, as well as the catalyst. The differentiation from other competitors in this field are that we don't use any organic solvent, so solvent-free, which is toxic, because solvent is toxic and quite expensive. And the reaction temperature is only 180 or 200 degrees Celsius. And while our competitors use such as 600 degrees Celsius for pyrolysis, and when it comes to gasification, it uses higher than 1,000 degrees Celsius. We can tackle also organic waste, including cellulose, lignin, which is like waste from wood or bamboo as well, because these are one of the most difficult organic waste to decompose. We can tackle like coffee beans, leaves, sewer sludge, paper sludge. And again, the reaction is almost the same conditions, 180 degrees Celsius. We don't use any solvent. And the catalyst itself, we don't use any precious metals. It's like normal metals that we can use for the reaction. And in this case, from organic waste, we get mainly hydrogen, or CO, which is carbon monoxide. So if we synthesize both hydrogen and CO, we can make SAF, sustainable aviation fuel, or a bio diesel or bio engine for a biofuel. The current challenge for biofuel or SAF is that the other companies, mainly in Americas, use they compete with food. They take the corn, starch, and so on, that competing with the food. But our case, we don't use any food, but we just use waste or organic waste, which otherwise put on the landfills. We have mainly three business models. We can have joint venture with a large company for chemical recycling facilities, but also we can provide our licensing based on the patents, or manufacture catalyst, which talks the core technology on this chemical recycling processes. The market is growing. We are receiving a lot of inquiries from chemical companies, oil and gas energy companies, but also the companies that emit have a lot of plastic waste. For example, like sportswears, wire and cables, also PVC, which is from medical plastic waste, and multi-layered plastic waste from automobile industry as well. We are testing right now at a few 100-liter scale, And soon we are testing a few ton scales so that we are seeing some commercialization within a few years. We are working with a couple of reactor manufacturers, and actually more than 10 chemical companies in Japan, in Europe, US, and in Asia. We got awarded a couple of foundations on the plastic and waste competitions, such as from Alliance to End Plastic Waste, Solar Impulse Foundation, and Clean Tech in the UK. We have around 30 members. We have bases in Kyoto, Keihanna. We have a laboratory in Keihanna. We have offices in Tokyo, Luxembourg in the UK, in Cambridge, and are mainly chemical engineers or material science. So actually, not only on catalysts for plastic waste but organic waste, but also we have, as I mentioned, we have two different technologies. Mainly one in the middle is the technology for carbon capture. So we can capture CO2 inside in the buildings and turn them into glass or cement that we can mix with. And we already have a couple of contracts in Asia and in Europe that emit CO2 in their offices, like commercial buildings, but also that sell glass products such as perfumes or the like bottles for alcohol, like a beer and wine. We also have technology in the bottom that the digest organic waste, and we can make methane for energy generation or generation of the heat on site instead of large capacity of digestion. So our clients are mainly that the companies that own the buildings or emit organic waste, such as from food factories and so on. So if you are interested, I'm happy to answer your questions or discuss a little bit more detail about these three technologies. Our next funding round is going to be mid or end next year. So we still have time, and happy to discuss a little bit more details. And also for the companies that have some waste, both for plastic and organic waste, and happy to discuss for new way of recycling. Yes, that's all, and thank you, and happy to answer your questions, Darren.
Yeah, thank you very much, Mr. Kubo. Now, here we can take questions, and sorry that I should have mentioned earlier, but if you're joining online, please use the function, Q&A function of the Zoom for raising no question. Here we can take questions, even though it is submitted throughout Zoom online. Also, from the venue, if you have any question, we're happy to take them. ご参加の方でご質問おありの方いらっしゃいますでしょうか。Sorry, however, it is reaching out to 4:30. Almost the time is to move on to the next presentation. But are there any questions? No. If not, please kindly visit the booth behind this stage. So each of the presenter will be available in this venue throughout the event to make some demos or answer your questions within here. So if you're joining on site, please kindly visit the booth afterward. So thank you very much, Mr. Kubo, again.